Good. I think we can start now. Good afternoon, good morning, good evening, wherever you are. Welcome to this webinar, Taming the Rain, hosted by IWD, the International Association of Water Service Companies in the Danube region, as well as Aqua Publica Europea, the Association of Public Water Companies in Europe. My name is Katharina Schilling. I'm the head of the IWD Secretariat, and I will co-moderate today with my colleague Milo Fiasconaro from Aqua Publica Europea. Milo, over to you for a short introduction.
Yeah, thanks a lot, Katharina. Milo from Aqua Publica, indeed. Good afternoon also from Brussels. From this network, Aqua Publica, of public water utilities at the European level, a network created 15 years ago to address common challenges in the water sector through collaboration and knowledge sharing among our members. Today, our 70 members provide water and sanitation services to around 80 million European citizens. Well, what to say, that with the dramatic events happening now in Spain, dramatic events that follow, by the way, months of devastating floods across most of Central Europe and also in the Mediterranean area. I mean, it's clear that there is an urgent need to step up efforts to build resilience against climate change and extreme events. Nature-based solutions represent certainly a tool, though not the only one, to address too much but also too little water. And as Aqua Publica, we have been working on this issue for some years now through initiative and joint project, and we will launch soon a publication. So we were very happy to team up today with our colleagues from IWD to further discuss the potentialities, also the limits maybe, on nature-based solutions. And we will do this through a review of good practices from a variety of different geographical contexts, medium-sized cities on coastal areas, some big metropolis, but also more rural contexts. But I stop here and I hand the floor back to Katharina for a proper introduction to the webinar and to the speakers. Talk to you soon.
Thank you, Milo, for that. Yeah, before we start, I would like to have a very short slide on housekeeping. Just that you know, this session will be recorded and made available on demand. And following this webinar, the on-demand recording and also presentation slides will be published on our websites. Even more important is that we have two tools here to interact with us. One is the chat box. Please use that one for general requests or to introduce yourself to the participants. But if you want to ask questions, please use the Q&A box so that your questions can be sent to the panelists. And in the Q&A part or after each presentation, we can respond to burning questions and can then go into the further discussion. Please also note that we cannot respond to any raised hands. So let me stop sharing now here. Those of you who know the Danube Water Program KnowNow series might have realized that we have slightly extended the time frame from 75 minutes to 90 minutes. The reason for that is because we have 4 very good speakers lined up for you with interesting presentations. So without further ado, I would like to invite the first speaker to talk to us. This is my dear colleague, Florian Kretschmer, senior scientist at the University of Natural Resources and Life Sciences with a vast experience on stormwater management. And he will provide a short overview on the topic of stormwater management to you. So Florian, over to you. The floor is yours. Thank you.
Kati, thank you for your introduction. Just let me share my slides. Can you see them?
Yes.
Okay. So it's my great pleasure being here today for this webinar and just giving you a short introduction, a brief overview on stormwater management. What has been stormwater so far and what's the, let's say, road we are heading to could look like. When we talk about stormwater management, in my point of view, it's very important to consider not only the stormwater itself, but to have the entire urban water cycle in mind. And this is somehow displayed on this slide now. So first, usually we have in our settlement structures, we have water demands. For that, we have water supply utilities. They get water from spring sources. They get water from surface water sources. They provide appropriate potable water for our settlement structures. And in this settlement structure, the water provided will be consumed for various purposes. Of course, we have our domestic water demands for toilet flushing, for showering, for the washing machines, for kitchen purposes and the like. But we also have industrial purposes and we have commercial purposes. And all these, let's say, locations use the water, and by the water use, we produce wastewater, domestic wastewater or commercial or industrial wastewater. And this wastewater today is usually discharged to a sewer system, and the sewer system is connected to the wastewater treatment plant. Can you see my pointer, by the way?
No, unfortunately not. At least I cannot.
Then I will try to change that. Can you see it now?
Yes, now it's possible.
Okay, excellent. So in the settlement structures, we consume the water and produce wastewater. We have wastewater generation in domestic areas, in the industry and in the commercials, as I said. And the wastewater usually is discharged to the wastewater treatment plant, where the wastewater is treated and the treated wastewater discharged to the receiving waters. So this is somehow the second topic we have in our field. So we have the water supply utilities. We have the wastewater discharge, wastewater disposal, wastewater treatment utilities, usually. But we have another water which is relevant in urban areas, and this is, let's say, the topic of our webinar, which is the stormwater. We have precipitation in urban areas. And urban areas are highly sealed. This means we have roofs, we have streets, so the precipitation occurring in the urban areas cannot infiltrate anymore, cannot be stored on the surface, but it will be conveyed to the sewer system and will be discharged out of the city. We have two possibilities to get the stormwater out of the city at the moment. It can be either together with the wastewater itself in so-called combined systems, where we have one pipe discharging the stormwater together with the wastewater from households, industry, or commercials. Or we have what we call a separate system, where the wastewater itself goes to the wastewater treatment plant, but the stormwater itself will not reach the treatment plant at all, but it can be either discharged to the receiving water directly, or it could be managed in another way, in a, let's say, more innovative way, where the stormwater will not be discharged anymore, but will be managed on a local scale. So we have the possibility to infiltrate the stormwater again. We have the possibility to store the stormwater somehow, and to also to allow evaporation of the stormwater again. So this is somehow more the nature-based approach again. We could close this, let's say, small water cycle again in the settlement structures. What is important to mention, and I will come back to this when we briefly talk about the new wastewater treatment directive of European Union, is so far the urban water management is very fragmented. We have the water supply utility, we have, let's say, the wastewater treatment utility, and we have somehow a sewer operator utility. This could be municipal, this could be a board, could be involved with the treatment plant, but usually it's very fragmented. And when we think of innovative concepts for urban stormwater management, it becomes even more fragmented, because this involves urban planning, this involves urban green and other disciplines. So please keep this in mind, that our, let's say, practice so far was more a very, very fragmented way of tackling the issue. And this is something we should reconsider in the future. So I was mentioning this more innovative approach of stormwater and then the conventional way we had. So when we think of the characteristics of those two approaches, we can think of the structural design of the components. And usually our existing drainage system is based on an underground pipe network and underground structures like manholes, like pumping stations, like storage facilities and the like. And the more innovative approaches now, which are either called blue-green solutions or nature-based solutions, they mainly can be found above ground. And they often also include vegetation, which can be clearly derived from the name blue-green already. When talking about the aims of those two approaches, the conventional way of discharging stormwater out of our settlements had the aim to protect the settlement from pluvial flooding. This is also somehow, of course, addresses human health issues. But the main thing, this we always must keep in mind, the main thing was to protect the settlement structures from urban flooding as best as possible. We want to avoid the stormwater in the basements. We want to avoid stormwater in the subways and so on. Of course, we now observe a change in rain patterns due to climate change, and for that, we can really observe that innovative solutions are coming more and more into discussion. Because the big advantage, or what we expect that these innovative solutions could provide, is to give relief on the existing sewer system. So our settlements are still growing. So the cities are expanding, so we have more paved areas, we produce more runoff, but the sewer system, of course, cannot grow in the same speed as the settlements do, and therefore we need alternative solutions to keep the additional stormwater away from the sewer system. Another big aim, or another aim of these innovative solutions, can be that as those structures are above ground and often involve greening, they can help to mitigate urban heat island effects. We observe also due to climate change very hot summers, and blue-green infrastructure or nature-based solutions are considered to be supportive in this context. And of course, green areas can provide space for human recreation, but it can also provide living space for flora and fauna. And as we're all aware, apart from climate change, the loss of biodiversity is even more challenging and more crucial on a global scale. So the provision of additional living space is also considered a very helpful and important aim of these innovative blue-green or nature-based solutions. Coming to the main functions of these stormwater management approaches. So for the conventional system, it's mainly discharge. And the innovative solutions can provide other functions like the infiltration into soil again, like storage or retention. So this could cut off discharge peaks, for instance, or it makes the water available for later use, or it makes the water available for local evaporation or even evapotranspiration, which again helps different purposes. So basically, we have different main functions, and this is also an important issue to have in mind, that conventional systems can fulfill certain purposes, innovative systems can fulfill other purposes, but of course, the conventional infrastructure is here, so we have to keep this in mind. And both concepts also face important challenges. So as I already mentioned, in our urban areas, we observe an increasing in surface sealing. So we produce additional runoff due to more areas where water cannot infiltrate anymore. In the same time, we observe an increase in heavy rain events, which give additional, let's say, which give additional runoff, which can pose a problem for the sewers, leading to sewer overflows, leading to pluvial floodings. And of course, since the stormwater in our conventional systems cannot infiltrate, cannot be stored on surface or cannot evapotranspirate, we have a great impact on the small water cycle. So the water is discharged and cannot be somehow be used or whatever on site where the raindrop meets the ground, for instance. And this can have an impact on the receiving water as well, not only from a quality point of view, because I think you're all aware that street runoff can contain quite notable amount of pollutants, but it can also provide an hydraulic impact on receiving waters. So maybe not for the Danube, but for smaller creeks or rivers, if we have a settlement structure which provides runoffs in, I don't know, several hundred liters per second, for instance, this can be hydraulic stress for the receiving waters. And this is also something we actually want to avoid. So basically some problems and challenges with the gray infrastructure, and innovative solutions can help to solve the problems we have with the conventional ones. However, also the innovative solutions face certain challenges. And one of the major challenges is the space availability. We are talking about the built environment. We are in the cities. So usually there is no free space. We have streets, we have pedestrian areas, we have places, parking lots, and so on. We might have some parks or trees or whatever, but basically the space in the cities is used. So if we want to implement innovative solutions, we need space, and this will certainly need to solve usage conflicts. On the other hand, it's not only an issue that we might have too much water, but we can also have water scarcity. And when we think of blue-green infrastructure, the green needs the blue. And especially in summer seasons, we observe long periods of no rain. And then the green infrastructure cannot deliver what it should, evapotranspiration, urban cooling, and the like, if it lacks water. In addition, all surface constructions, new ideas, they cost quite some money compared to, let's say, the existing solutions. And we also lack the institutional framework. So we are quite aware how to deal with the planning and the construction of gray infrastructure. For the blue-green infrastructure, this is coming, but it's still a lot of questions. And when it comes to operation and maintenance, when it comes to a life cycle perspective, the innovative solutions there, we still have a lot of lack of regulations and the like, and also of responsibilities. This brings me almost to my last point, to the recast of the European Wastewater Treatment Directive. We had the old directive, I cannot remember now how old it actually was, but quite some years. And of course, this was a nice directive, but of course, there were some open points. Basically, three major open points could be identified. The one was that we still have remaining pollution from urban sources. We have new pollutants, but we have stormwater runoff, for instance. Then we have gaps in relation to the Green Deal, which mainly deals with renewable energy, energy efficiency, but also with circularity, which brings us also to the stormwater reuse topic, for instance. And there is certainly some optimization potential in terms of governance towards transparency in operators' performance, monitoring, and so on. And these open points, of course, also have a relation to stormwater and to blue-green infrastructure or nature-based solutions. Because when we deal about stormwater pollution, we have stormwater inlets to the receiving water. We have combined sewer overflows. And there, those inflow points can be a point of pollution for the receiving waters. So this is an issue we certainly have to tackle for the upcoming years. Another thing is the reuse. I mentioned in my first slide, we are very fragmented at the moment in the water sector. We have water supply utilities, we have wastewater utilities, and so on. Basically, today in urban areas, we mainly use drinking water for all the purposes. For the drinking water and human purposes, it's quite clear. But for street cleaning or for irrigation, this is not so clear whether we should use drinking water for that or whether we should better substitute it with, for instance, stormwater. And finally, we have to intensify the entire stormwater monitoring, not only at the CSOs, which is a big discussion at the moment, but also at the stormwater inlets themselves. And just to conclude, some take-home messages. So climate change, we're all aware, is a major challenge for urban water management and, of course, for urban stormwater management. On the one hand, because we have extreme storm events. On the other hand, we have long dry periods. The existing infrastructure, the gray infrastructure, is here. So it's no need to reinvent the wheel, but we need a combination of the existing conventional assets we have and of the innovative solutions. And finally, we need integrated thinking. So it is not helpful if we think, let's say, in a drinking water perspective, and in a wastewater perspective, and in an urban green perspective. We have to integrate the different stakeholders, the different perspectives. Also to develop appropriate institutional frameworks to deal with the new challenges. And we need life cycle perspectives and life cycle concepts. Today, we plan the blue-green infrastructure, the nature-based solutions. We build them, but the operation is a big question mark still. And if we, let's say, tackle these issues, we will also be somehow prepared to tackle these challenges of the new wastewater treatment directive. So this is what I had. I thank you very much for your attention.
Thank you, Florian, for this short introduction into stormwater management. I see we have an immediate question from Peggy in the Q&A box, and she's asking, how are pollutants from stormwater currently addressed or managed with both solutions, avoiding polluting the environment? Can you maybe give a short response to that, please?
If we have a combined system in the city, so when we have a sewer network which transports the wastewater from households and so on, and stormwater to the treatment plant, the polluted stormwater, or at least the first flush of this polluted stormwater, will anyway be treated in the treatment plant. If we have separate systems, we often observe that there is no treatment at all at the stormwater inlets, and this, of course, can be a threat or an issue for the aquatic environment. So these direct inlets is still a big question mark at the moment.
Thank you, Florian. May I ask you to also unshare your screen, because now we are coming to our second speaker, Ms. Cemre Erbil. She's an employee at the Research and Development Branch at the Istanbul Water and Sewerage Administration, İSKİ in short, in Turkey. And she will introduce İSKİ's project on early flood warning system for Istanbul. Cemre, the floor is yours.
Thank you so much. Can you see it?
Yes.
Okay. Hello, everyone. Thank you for introduction, Katerina. Today, I will talk about an important system aimed at making Istanbul safer from risk of the flooding, Istanbul Flood Early Warning System. As you know, flood disasters are events that can have serious consequences, especially in large metropolitan areas. In rapidly growing and densely populated cities like Istanbul, leveraging technology to minimize the risk posed by potential floods has become essential. So it's our system purpose is predict the predict the loss of life and predict the flood risk. Predict the flood risk. Okay. Today, before I will talk about early warning system, I just want to mention that what is the flooding? Flooding actually is one of the most frequently occurring natural disaster and caused by heavy rainfall and river overflow. It's occur when water spill out of control and submerged lands. As you know, flooding can cause two type losses in our life, tangible and intangible losses. Tangible losses are physical damage like destruction of our home, road, or infrastructure, but intangible losses, on the other hand, more abstract effects like erosion of our science and piece of safety. And causes of flooding, many factors can cause of flooding stemming from both natural and human activities. For example, prolonged rainfall, heavy rainfall, relief, geology, vegetation, and urban land use. The another factor is actually climate change. Climate change is one of the biggest factor in occurrence flooding and caused by excessive rainfall and sea level rise. And climate change increases the risk, escalating both frequency and severity of natural disaster. The another factor is deforestation and urbanization also increases the flood risk, reducing by natural water absorption and increases runoff into river and stream. And according to the Turkey Disaster Management and Natural Disaster Statistics prepared by AFAD, 38 floods occurred in Istanbul from 1950 to 2018. In our country, 1,235 people lost their lives due to the floods. Lots of houses destroyed or rendered, and the bill resulting from flood alone researches $4 billion. And we can examine flood prevention strategies under two main categories, hard engineering and the soft engineering. Hard engineering includes building solution like infrastructure solution like building dam and reservoir or measure river strengthening or create flood relief channels to help control water level. And soft engineering includes more environmentally and friendly solution like flood warning system, flood planning zoning, afro-restoration, and ecological flooding to aim reduce the risk preserving of natural disaster, natural environment. And up until now, we as ISKI work on in general hard engineering, but now we start to soft engineering. What is flood early warning system? Actually, it is a system that prevents loss of life and property by predicting flood risk. The system identifies the flood risk using data from various sources like water level, rainfall, or terrain to issues warning to relevant authorities and public. And Istanbul Flood Early Warning System was developed by Istanbul Water and Sewerage Administration. This system is supported by InfoWork ICM and InfoWork ICM Live software. These tools have 1D and 2D model capabilities and integrated hydraulic and hydrological data for high accurate forecasting. Thanks to this software, we can simulate wastewater and stormwater network. For example, if there is a heavy rainfall in area, we can predict how the water move and identify the area at risk. And there is video here. This system uses actually real-time weather data from Generate Directory of Meteorology and provides instant update and warning in risky situation. And rainfall alarm are automatically generated based on model result and sent to a field team via email. The real-time warning system is major advance for fast and effective intervention during emergencies. And to illustrate the system functionality, the pilot project has been carried out in Cendere Basin in Istanbul, where daily flood maps are produced. The pilot project has been a very important step in testing the system effectivities. For early warning system, the first step is rainfall forecast, and then hydrological modeling. So finally, hydrodynamic modeling. Flow measurement. Actually, we can determine the change in the water level with stream gauging station, flow meter, and dome cameras. But we are currently in the first stage, and we only work with simulation, and the system sends an email according to simulation result. When we move on to second stage, the model result will be compared with the real result, and the alarm will be given accordingly. Actually, we have just started this work, so we believe that it will develop over time. Disaster management. We can examine disaster management in three main stages: pre-disaster, during disaster, and post-disaster. In pre-disaster stage, preventive measures are taken in high-risk area using high resolution data and risk maps. During disaster, real-time data flow enables rapid and effective, accurate response by directing field teams. In the post stage, quick damage assessment are made, repair work begin. The assistance is delivered to those in need here. And ETIOS disaster management system. Actually, ETIOS is Istanbul flood early warning system here. The system first simulates flood risk using meteorological forecasting along with hydrological and hydrodynamic model. And then flow estimates are obtained from model result and then compare with the real-time hydrodynamic model. After all of this process, if the risk is high, the system sends a warning to authorizes. Planet activities. Actually, the development of ETIOS is ongoing now, with some planet project and activities aimed at strengthening this system in the future. These plans include integrating new data, updating hydrodynamic model, and adding higher resolution weather forecast to the system. With these improvements, İSKİ's flood early warning system will make Istanbul even safer. And the cost of ETIOS, actually, we are in the stage 1 and we use the perpetual license, but the license type is no longer available. Annual fee is charged now. For stage 3, the pricing is not yet determined in accordance with the public procurement law. Thanks for your interest.
Thank you, Cemre, for this presentation on the early warning system for flooding. In Istanbul, I can see we have one burning question here from Theodore. He is asking who is financing the infrastructure and who is paying the operational expenditures. Maybe you can give us some insights on that.
Actually, İSKİ, Istanbul Water and Sewerage Administration was funded it. According to, maybe, you know, we have master plan for İSKİ and scope of master plan. We buy it, this software, and then, but we just in the first stage.
Okay, thank you, Chandra. Then I may ask you to unshare your screen and we'll
Okay.
go to the next presentation. Next in line is Tatiana Ujelats. I hope the pronunciation was correct. She's a graduated civil engineer and the CEO of a company called Starom in Pula in Croatia. And she's a long-term collaborator of the city of Pula on topics such as development of green projects with a focus on stormwater management solutions based on nature. And she will present the rain gardens of Pula. Tatiana, the floor is yours. Thank you.
Thank you. Can you see?
Yes. Please just go to presentation mode. Thank you.
I'm trying. I don't know what's the problem, but I will try again. Is okay now?
I cannot see it in full screen mode, but I mean, just go through the slides as they are, just to not lose more time. I think they're big enough.
Okay. I'm so sorry. Something
No
wrong.
worries. I know it worked before for whatever reason.
Okay. Let me see. It's okay now.
Yes, it is.
Okay. So I'm from Pula, and we have a big problem with flooding. And the title of the presentation or the webinar, Taming the Rain, I think that we cannot tame the rain. Why I'm saying that? Because this is a little dangerous paradigm. According to the EU Green Deal and Green Infrastructure, landscape architects here in Croatia think it is good enough to plant trees and bushes together with landscape design to tame the rain. But what if we have impervious soil like the one we have in Pula? We cannot even mitigate climate change for now, and we have to adapt. I will show you in the following slides, and I will present MBA's case studies for Pula. Yes, we solved the problem with rain, with flooding, but we have to change our way of thinking. Pula had big problems with floods for the following reasons: topography on the lower point of Istria Peninsula, old sewer channels, mixed sanitary and stone water, sudden urbanization and spatial plans that did not recognize changes in runoff, and additionally high-cost stormwater, sewer which cannot follow the rapid urbanization, short-term heavy rain related to climate change, and underground impervious clay soil. It was looked like that. Floods in Nazarova Street, King Tomislav Square, Šijana Watershed, Oloshinska Street. The first pilot project was in Nazarova Street, and we have used rain gardens with a drainage layer, drain cells to collect more water, and infiltration trench for parking lot. This is the rain garden during the rain and after the 24 hours after rain. Used MBS systems, rain gardens, and the infiltration trench, like I said. And we had used MBS solution with 3 rain gardens, underground retention, the drain cells, and infiltration trench for the parking lot. Calculation method was rational method, and the pores in drainage layer between gravels in the drainage layer are water volume, which keeps water in the drainage layer. Porosity is, for example, between 30 and 40%. So if we have stored to 100 cubic meters, we have to calculate with storage 70 or 80 cubic meter. This is a cross section, and for direct flow and indirect flow. Direct flow from pavement or parking lot, and indirect flow can be used from city sewer. The second slide or the next examples is the town beltway. Although the project was already finished, it was found to be too expensive, and then oil and grease separator for stormwater treatment was not available, and it was too big. We also applied the MBA system here. Picture shows the construction of the infiltration trench, its cross section, and the difference between the classical and MBS approaches. Classical approach is as soon as possible, like in sanitary sewer, but MBS approach is slow the flow. We use the modified Santa Barbara method for calculation. So we first calculated and choose the design storm from DDF curves. So we can we first calculate a hydrological study, and then temporal distribution of rainfall intensity for design storm, and for 4 duration places at Pula station and time series from 1957 to 2017. With that calculation, we made the Excel table on our own, because we don't have here any rules, norms, and all needed material we get from USA Protection Agency, Environmental Protection Agency. And this table shows, this Excel table shows in the light orange color, the Excel table calculate without the perforated pipe in drainage layer, and the blue part shows the calculation with the integrated perforated pipe, because we have impervious soil and we have to store excess water on another place or another recipient. A small picture shows the flow hydrogram without and with the perforated pipe if the soil is impervious and we cannot directly infiltrate the stormwater underground. With this Excel table, we can check the water depth in every minute per 24 hours in the drainage layer, and we can choose on which height we will put the drainage perforated pipe. The next example is King Tomislav Square. Picture shows architectural design and hydrotechnical design with rain gardens and underground retention. We used the rational method too, with a return period of 100 years and duration of rain of 24 hours. We used 16 rain gardens, underground retention, and infiltration trenches for 2 parking areas. And the plants we used, grasses such as Panicum virgatum or similar, carex or similar, are for purification, and trees are for reducing urban heat island and sequestration of CO2. We used underground retention with storage volume of almost 6,500 cubic meter. The next slide is interesting because the town department did not allow stormwater discharge from private parcels directly into the town's combined sewer. We had almost 500 liters per second from the city mall area, and the town department allowed only 20 liters per second. So we used rain garden and underground retention. And before the discharge, we had to control the amount of discharge. Before connecting to the town sewer, we had to use a mechanical flow controller. This is simple metallic plate built into the main manhole. And during a heavy rainfall, controller will be activated. Works in principle in different pressure between water level in city sewer and water level in manhole. And the rain gardens and retention will be start recharging. After heavy rain, water from the rain gardens and retention will be slowly discharged in the city sewer. Of course, we have to make the mathematical model for whole area. This is another example. This is Loshinska Street, and how can we protect the downtown area from hills water? We use hill retention and dry walls, check dams, rain gardens, and the end of the street pond for excess water. These dry walls inside, this is a dry walls inside before planting, terraced terrain, construction, and pond at the end of the street. Šiana watershed is approximately 500 hectares in size. The drainage from the Eastern Highway ends in the city, so we have to build lagoons in the center of roundabout to collect that water to save the city for flooding. There are 5 wet and extended retention lagoons in the entire basin. Drainage from local roads is solved through rain gardens. After several built systems, we analyzed these MBS systems and we concluded that they are much cheaper and significantly reduce the pollution burden. SWOT analysis shows strengths and weaknesses and opportunities and threats. Strengths protects property from water damage and flooding. It provides ecological solution, rainwater harvesting. Weakness, lack of regulation. The connection between concept and construction is not well established. Some stakeholders are also yet to be convinced to effectiveness of MBS methods and practice. The future approach focus on urban space planning, publicly visible, technically simple and beautiful. Threats, the biggest threats are lack of knowledge and so on. And this is an application guidelines for designers. First, for designers, the drainage system should take full advantage of existing vegetation and natural drainage. If possible, build the drainage system before constructing the building. The design begins with the discharge of collected water. The calculated discharge quantities must not exceed the existing downstream capacity to reduce the possibility of flooding, erosion, habitat degradation, and the burden on the existing drainage system. Design so that the drainage system requires minimal maintenance and cost. Drain surface water to permeable and green areas and depressions to increase infiltration. Apply terrain shaping techniques and use depressions for water storage and infiltration. Design retention space with sinusoidal banks to ensure more space for littoral vegetation and greater number of plant species and better aesthetic impression. Place entrance buildings and water intakes in grassy areas, not asphalted ones. On traffic areas, use gutter construction with side openings for even distribution of inflow over nearby grassy areas and ditches. Locate protective buildings within the road belt, dividing belt, or traffic junction. Application guidelines for planners. All plans must have the possibility of the MBS systems. The management of precipitation inflows at the planning level for each location should be based on and be in accordance with the plan of the entire basin. Water knows no administrative boundaries, like I said. Runoff before and after construction should be the same. Maintain or reduce runoff coefficient by applying the MBS system. To the greatest extent possible to maintain the permeability of the soil, reduce concreting, increase water retention in the basin and reduce the size of the inflow by landscaping, use the existing relief when building parts of the drainage system, make maximum use of the natural environment, increase infiltration and filtration, and reduce flow rates and erosion by landscaping the watershed. If possible, envisage the use of purified rainwater, especially in agriculture. Where conditions exist, multi-purpose facilities should be planned or in the immediate vicinity. Prescribe the use of porous materials in the construction and squares and streets in the old city cores. Unbound stone and porous asphalt or concrete or similar in low-lying parts of the settlement near busy streets or either parking and pedestrian and bicycle paths. Methodology for micro scale. Analyze possibility of water remining in the natural basin, analysis of engineering geological maps, hydrological study, IDF and DDF curves, then choose design storm, analyze the runoff coefficient due to spatial plan, analysis of the watershed according to natural and anthropogenic factors, in situ infiltration measurement, planning of the main drainage channel, recipient, determination of the recipient, determination of one or more landscape techniques depending on the part of the settlement and the size of watershed. Calculations are made according to the adopted methods, SCS, rational, Santa Barbara, modify Santa Barbara with perforated pipes, etc., especially for high density urban areas with impervious soil. Planning and arrangement of roads, part of settlement, park of square, as well as drainage channels and landscape inseparable from each other.
Tatiana, may I just ask you to come to a close because time is out? Thank you.
Thank you. And this is methodology macro scale for spatial planes with GIS technology and heart rate software for pilot projects Split, Zadar, Biograd na Moru, and Poreč, Gospić, Metković with Interreg Italy, Croatia stream. And we use the catchment scale, city scale, sub-basin scale. We try to recognize hazard. Hazard is water depth, water velocity, and flood severity. And the combination of this hazard, we can calculate flood risk and direct damage. And for Croatia, direct damage is amount 278 euros per square meter. And this is a historic flood for town of Poreč with a hydrodynamic model. And what is important, we can predict flood for chosen design storm. And finally, why we cannot tame the rain. People are part of nature, but imitating nature as whole excludes human activity, and thus they very exist to people in certain area. Our opinion is that the holistic approach to the problem is the only correct solution. Nature itself, without human activities, will adapt perfectly to climate changes, but people must survive too. That's why we have to find semi-natural solution, and what we have shown from the above examples. Thank you for attention.
Thank you, Tatiana, for your presentation. Given the tight timing, we will not have any immediate questions right now, but I would like to hand over to our final speaker, Frank Peru. He's coming from SDEA, and Frank, I will let you introduce the full name, full French name of your association, because my French is horrible, so please forgive me. And Frank will talk about managing water with nature-based solutions in rural and urban areas. Over to you, Frank.
Okay, thank you. Hello, everyone. I'm Franck Peru from the Syndicat des eaux et de l'assainissement Alsace-Moselle. It's a local water and wastewater and river management utility in eastern France. I don't know if you can see my screen.
Yes, we can.
Does it work? Okay, let's go. As I said, we are quite a rural facility. We manage 4 competencies in eastern France, in the Alsace region. We have a water responsibility, drinkable water responsibility, which we won't talk today, obviously. But more importantly, we manage both wastewater and river management, which will have some consequences I will show you afterwards. We manage more than 10,000 kilometers of networks. Half of them are wastewater networks. And the very vast majority of our networks are combined, mainly for historical reasons. When they were built, our predecessors were told it was better that way, and we had quite a big reversal about that on the last 10 years. So we have some very visible effects of pollution here in rural Alsace. We don't manage big cities. Strasbourg is independent, so we have small cities to manage, and we are prone to flooding from our own sewers and from external reasons. So our main impacts of big rainwaters are floodings and overflows, and our objectives are to reduce floodings. Evidently, for our population, it's quite important, and we have an objective on French law, which is we have to keep combined sewers overflow under 5% of the rating of all the water which come into them. The next European objective will be 2%. So we have quite a big gap to share on that. So our small cities are prone to flooding from 3 layers of flooding. The first one is from upstairs. You have small rivers there, and they can flood your city. You have a secondary effect is in there that flows cannot discharge on the water if the water is of the river is higher than your overflow. So it's our first source of flooding. The second source of flooding, and the most important here, are from mudslides, from farmlands. You have a big river basin and a big concentration catchment area basin, which will come into your city from upwards, and the city is flooded by its own farmlands. And you have internal flow from the urban runoff, which you saw before. We are also victim of. So we use a 3-tier preventive plan with the main stages you all know that are avoid, reduce, and compensate. And on all our practices, we tend to associate various partners. Our main partners, essentially on mudslides, are the farmers themselves. We have to cooperate with them to reduce mudslides, mainly by better farming practices. And secondly, we can do something on the river restoration, on soft hydraulic practices, which are in BS, by the way. And secondly, we use traditional hydraulic techniques and runoff diversion, which are gray techniques. I won't much talk of today. So we tend to first cooperate with farmers, and secondly with cities to permeate cities. I will show you some examples there. First layer, mudslides. Mudslides. You have 2 solutions there. Better farming practices, farming practices which will include no plow techniques, because if you plow the soil, it tends to be more prone to mudslides, and you may have a better crop selection. We have a big array here of crops. The most problematic of them is corn, because corn tends to grow after the period in which we have the most storms, which are late April to June. So we cooperate with farmers to change their crops, which will in turn diminish the flow we tend to have on mudslides. And we have curative approaches, which are small rural hydraulics, mainly from hedges. You can plant hedges, small trees you find on French farmlands, and more exotic ones like miscanthus, or more technical ones like beamed edge. All three solutions tend to work quite in quite a good fashion. We have some results there, which were financed by a LIFE project. We have a very good mudslide limitation, and we tend to cooperate with cities too. And our urban planning is now considered to be more resilient. You have to adapt your city to the mudslide will happen as good as your solutions are, because you cannot tame more than I think 30 or 40 period events with those solutions. So quite the big events will have to be taken into account differently by urban planning, and by letting the flow cross your city than flooding it. So we planted a lot of trees, and we tend to now plant a lot of hedges to limit those flows from farmlands. You have to limit the flow from the river. Those are quite classical now solutions to manage rivers. You have to manage the river from its natural course. You can't rectify rivers. You have to remender them for the flow to be slowed. And you can combine those solutions with the solutions we saw before, like hedges, to limit the flow coming on this image from the left. And you can combine that with floodable. It will flow on the meadow and not on the city you have downstreams. You have some quite good by effects there, like biodiversities, like more agreeable states of the river, which can be quite good to convince local elective and farmers. Other solutions we have are our last line of defense outside the cities are floodable meadows. You build, and we have quite an array of those. You create before the city a little meadow, which will tend to take the small events. The mud is blocked on your meadow, so it's better for the grid afterwards. And you can infiltrate small events, so it's less rainwater which come into the city, and it's quite a good technique to do if you have some space upwards your city. And in the city properly, we use the techniques you saw before. So we tend to prioritize greener solutions, but we do not forbid ourselves to do more grayer solutions. The main problem here is to manage all that with other partners, which are the road departments and the cities, because you tend to have the solutions have to be taken into account with multiple partners, and a partnership is very, very, very important there. It's our main focus here. You cannot manage nature-based solutions alone. So some examples there. We have quite a big focus on those days on schoolyards because you have big surfaces on schoolyards. This one on photos represents a quarter hectare, and you can disconnect quite a big surface on schools. It has some good by effects because you have less island effects. You have best education to nature for teachers, and you have more gender inclusivity. All those solutions were made associating users. Users are evidently children, but to teachers, janitors, and the parents of our children. If you do that with them, your solutions are better accepted. So even in that, partnerships are quite important. Other solutions you saw before that are quite classical technique. Word disconnection. We tend to let the flow infiltrate itself on parking lots you have on sides on the roads, and we have some partnership for housing deconnection. We ask everyone to disconnect themselves from the grid. We pay a small tank to keep rainwater for themselves to irrigate their garden, for example. And you have a big acceptability of that if you associate the population themselves. They are two to be associated in that. So to conclude, you have to take into account a very, very big array of partners, but without them, you can go far. They are your main incentives, they are your clients, and without them, you cannot do anything. Thank you.
Thank you, Frank, for this interesting presentation. I cannot see any immediate questions right now. So what I would do now is hand over to Milo for the moderation of the Q&A session. Over to you, Milo.
Yeah, thank you, Katerina, and thanks a lot to all our speakers for very valuable contributions. I mean, at the beginning, Florian was talking about innovative solutions. One could argue that at the end of the day, we are going back to nature. I mean, shouldn't be so innovative. We are just rediscovering the use of nature. At the same time, all the presentations that we heard today, I think show very clearly two things. One is that although we are dealing with nature, these solutions are based and require a significant amount of knowledge, studying, and modeling behind. The second aspect, as most of the speakers pointed out, is that, as also Florian was saying at the beginning, these solutions are complex from a governance institutional point of view and require a quite sophisticated governance and institutional articulation. And I think that this is two important dimensions that we need to explore. And these, I think, will be a bit the two things that we have now the opportunity to go a bit more in depth in this last part of the session. But before moving a bit to the discussion on this, maybe let's see if there are some pending questions from participants. And I also really like to invite again all participants to drop their questions in the box for the speakers. This is an opportunity for you to interact directly with them. So there is a direct question for Tatiana. There is still pending in the chat, which is, I don't know if Tatiana, you can see the question, and it's from Alenka. It's in the chat box. The question in any case is there any pre-treatment before rain garden from the streets, between brackets, oil separator, question mark?
No, because the plants are imitated the separator. All the purification is in the rain garden.
Okay, thanks. Quite clear to me. Please, Alenka, if it's not clear to you, don't hesitate to follow up question. And then we have a question for Frank. That is actually a question that we also had. I don't know, Frank, if you can read the question. In any case, it is, how easy is cooperation with farmers? Do you incentivize the better farming practice?
Okay.
Please, Frank, go ahead.
How easy it is? It depends from the farmer, of course. it may be quite simple if you embark their unions with you. We have the chance to have their main union directly across the street, so it's quite geographically simple. But the cooperation can be quite good because we come often with the same demands, and so they have to adapt. But it ups and downs. For the incentivization, you can use eco schemes from the CIP if you are in the European Union, evidently, because we can use them for that. Because in France, CAP is you have a gestion of the CAP by regions. So we talked with our region to incentive those techniques with them. So you have some eco schemes. You can resort to more local incentives, and if it does not work, you may have to use coercive solutions, mainly by buyouts or other solutions. We tend to avoid completely because cooperation is much easier to do.
On this, sorry, Frank, I have a follow-up question from myself. Just for non-EU participants, just for your information, Frank is talking about a specific measure, which is called Eco Scheme, which is part of the common agricultural policy of the European Union, so the policy that is financing farmers. And there is a specific measure that can finance farmers to take measures, to take actions that are good for the environment, to put it in a simple way. A follow-up question, Frank. You said that some of this practice can be financed through eco schemes. Could you also yourself, as a utility, finance with your own resources some of the practice? For example, the lands that you have along the river, the flooding part of the river. This land has been bought, or how is it managed?
The land is not bought, but we have a convention with the local farmer. We pay him for the loss of chance, loss of crops. If the area is flooded, he evidently cannot use anything, so we pay the loss of chance for the crop. And we have a small fee for him to use a crop which has a lesser output, economically speaking, than corn, evidently guaranteed, and bigger if he loses everything. For example, if your meadow is flooded entirely and you cannot take the hay which was there that naturally, we tend to have an economical incentive for that. We tend to avoid completely buyouts because they are perceived as hostile. So it's cheaper and better this way in terms of cooperation.
Thanks. The takeover of farmers by the water sector, that would be a great political innovation. Two more questions, Frank, for you, and then we move to other speakers. Two more questions from the chat, actually. One is just to Florian, but I think it's more for Frank rather than for Florian. The first question, Frank, is how could you force the customer to disconnect from the network? And the second one, are you going to merge nature-based solution for flood with protection of water bodies from nutrients impact as well? Good question. I think this is indeed the case, but I'll let you reply to that, Frank. Thanks.
For the first question, it's not a very good answer because we cannot force the customers in the actual state of French law, and I think in European law it's quite difficult to do that. So we have to be incentive around there. For the objective of 2% that is in our common law now, it will be on the next days. I don't think we can attain that without being coercive. So I think it may be a development of our common legislation on the European Union. But on the state of the law as it is today, we cannot force anyone to disconnect. It's quite simple at that.
You can also say it's the fault of European Union, of course. The second question on protection from pollutants and
from pollutants, the techniques we use and some incentive you have on the CAP and eco schemes tend to promote, in French we say, the culture intermédiaire. It's an intermediate crop you can put between the river and your farmland. There are strips of land around 5 or 10 meters, which tend to absorb nutrients and prevent them to come into the river. So it's a part of the solution, but it's something which is already implemented on French law. So we tend to combine those effects together to prevent mainly nitrates to come into rivers.
Okay, thanks a lot, Frank. I hope it's clear for the participants. Otherwise, feel free to ask further question to Frank. I would have maybe myself a few more questions for Tatiana and Semre. Tatiana,
I only add 2 words to the thing.
Please go ahead.
Forcing
Please.
the customers. On the one hand, I agree with Frank, so we cannot force existing contracts to be changed. But anyway, if there is new construction or reconstruction, authorities have the opportunity to say, okay, if you want to have building permission, you cannot discharge your stormwater to the sewer anymore. You need alternative solutions. In addition, I think companies, industries are anyway interested to show their good practice also in the context of EU taxonomy regulations. And finally, I think public hand could anyway be a forerunner to give good example, to disconnect parking lots, to disconnect public squares, to disconnect the public buildings. And I think if we achieve on those points, then there's already a lot of water saved from the sewers.
Thank you, Florian. Yeah, please, Frank, feel free to react to that.
One phrase, you can have the better incentive for me is taxation of rain discharges in sewers. We do not have that in France, but I know it's effective in some countries like Germany, England, so it may be a solution.
Yeah, and that's I can also add that this is, for example, in Belgium, is something that they are exploring regarding taxation. Certainly, this is a thing that we, as association, we are also a bit advocating on the European level. For the rest, thanks, Florian, for contribution. We take note, and indeed, this is more for the political work that we also do as associations with IWD as well. I would like rather to go back to more practical and technical question, which is a bit the nature of this webinar. So a question to Tatiana. You show at a certain point a slide with the projection or estimation of the savings of some of these measures. Could you maybe develop a bit more or tell more? Because I don't know if I missed something, but are saving compare exactly to what and how you calculated this saving a bit more? I mean, methodology, and also whether in this calculation you are including a medium term, let's say, maintenance costs of these solutions. I mean, because these, I understand, in many cases remain a bit a question mark, the medium long term maintenance costs. And then I also have a question to Serme afterwards. It's not clear to me whether, but first, congratulations, because as we were saying in the preparation of this seminar, real-time hydraulic modeling, it's a very complex affair. It requires a lot of knowledge and also technology on the ground. My question is to you is, so this is a flood prevention mechanism and for alert purposes as well. But are you planning, the city administration is planning also to use the results of the modeling, not only for the real-time case, but in the simulation that you're going to do for urban planning purposes. I mean, if you realize that an area is particularly at risk of flooding, is it planned that the public administration will use it also to implement mitigation measures that can address the problem in the medium term? These are the two questions, but let's start with Tatiana. And please, Tatiana, unmute yourself.
The old classical systems didn't work properly, and the department called us to try to solve the problem. So we always have the cost estimate calculation from old project, and when we design the new project, we have to estimate, and we know what's the difference. And the second question was, I forgot.
Maintenance cost. If
No,
this calculation
no,
does
no,
not
no,
include maintenance
no,
cost, okay.
No.
Have you
Unfortunately,
in any case collecting data also on this, or not really?
No, not really.
Okay.
No,
Okay.
Unfortunately not.
Thanks. Then I move to Samre. There is also a question for you in the chat as well, if you want to take also this one while.
Okay. And okay, actually, we are planning to apply it to all of Istanbul. And right now, it is only in the gender basin, you know. And we are receiving mail now. But in the future, we will send the warning to authorities for all of Istanbul.
Thanks. So yeah, and there is also I don't know. You see the question, Samra, in the chat?
Okay. Sorry. Yes, we have some cost, as I said in the presentation, $135 for license. We have already sensor. We don't buy it now because we have some working in according with the master plan. And we already have sensor for it. Just $135 for up until.
And sorry, Samra, on this, sensors are managed by the water operator, the water utility, right? Or they are managed by yourselves, by the who is managing the sensors?
We have İSKİ.
Okay, thanks for that. I go back to again to Tatiana. Well, one thing that I noted and it was quite interesting is that you mentioned that the knowledge, let's say, to realize, to design this measure was coming from the US Protection Agency. That's quite interesting. I would like to ask you whether, I mean, if you didn't find this kind of knowledge in Europe, how came that you found only in the US? And the other question for Tatiana is a bit following to what Frank was saying. I mean, on the other side, that is, in your case, the funding of these measures in Pula are coming from the city administration, or there is also a participation for the funding from the water operator side? Because some of the measure reduces the cost of water operation as well. So there might be an incentive or a rationale for the water utilities to participate in the realization of these measures, which is the case of, for example, of Frank and the SDA water utilities in Alsace.
Okay, the first question. My professor was an American student and doctorand, and I asked him. And on the internet you can find everything. I asked the question and I received everything. I want books, magazines, articles, everything. So from Australia too, the Melbourne is water sensitive, the center of water sensitive urban cities. And in Australia and the USA start with these MBA solutions in 19th century because they had a big rapid urbanization like we have now in Croatia in the last 30 years. And about cost estimate and measures for department and water supply companies, Australia here is a completely mess. And I don't know who paid which part of project. For designing always the city is the town of Pula paid the design always for stormwater. For water supply and sewer water, this is a communal firm.
Thanks a lot, Tatiana. And indeed, I mean, at least as Acqua Pubblica, we have been working in also with the European Commission in trying to understand how to facilitate natural-based solution their implementation. But the issue that Florian was mentioning at the beginning of the institutional complexity, who pays for what, who designed this, who is responsible, who negotiates with other city department, road planning, urban planning, agriculture, that's not, the governance of the thing is complex. But since we are moving towards in any case, something that we, it's ground for further work also as an association in the future. Before moving to the end and before leaving Caterina for some closing remarks, there is a last question in the chat that could be also a closing question for all of you. But please be short about so the question is so how do you consider future projections? I think the question is double for both Semre and Tatiana also, whether in your design have you integrating in your planning future trend in rainfall, and secondly, if you think that what you are doing will be enough to manage the future climate change based on what you know. For Tatiana already said a bit that you cannot tame the rain, but please feel free to develop on this.
Yes, with the new tools and AI especially, we can predict future changes in climate, but I don't know, it will be enough. And maybe is one beautiful sentence which I like to hear from Mr. Herbert Dreiseitler. It's a landscape architect from Germany, and he always says, please use common sense and it will be enough. We are living in time when we don't know what will be the next. Okay. And scientists, climate change is here, but it is climate change. It's not only human causes, but our scientists call it climate change as climate chaos, and we will see what will be.
Thanks, Tatiana. Semre, do you want to say something on that?
Yeah, actually, when we carry out work to this second stage, we will be in the better station, but it is not enough. We need to take more precaution, of course, but I am not sure how, unfortunately now.
Thanks, Semre. Florian, from an academic point of view, what is your take before moving? I want that Frank closes draw some conclusion from operator point of view of this discussion. But Florian, from an academic point of view, how would you reply to the question?
Before I answer this question, I think there's still one question left in the chat. Should we tackle this question as well?
Please, Florian, no, go ahead. Go ahead. Maybe Frank can reply in written form to the
Okay,
question.
no, anyway, so there's one question for the retention areas upstream of the cities. And in my point of view, this is very important. If you have rivers coming to the cities. In Vienna, a couple of weeks ago, we had severe stormwater incidents, and one of the rivers in the city had a high water of about 1,000. It was a 1,000-year event, and the flooding of the city and the subways was only prevented because of retention basins at the city gates. So this is certainly an issue. We have to, as I said, we have to have this integrated view. It's not only that we think of the city and we think of let's say the outer city. We have to think in hydraulic dimensions. So what is the catchment area? So we have to think, let's say, in an integrated way from a hydraulic perspective, and we have to think of an integrated way in a professional perspective. So it's not only about sanitary engineers, it's not only about landscape planners or whatever. No, it's a very inter and transdisciplinary issue, and we have to elaborate on that.
Thanks a lot, Florian. And this is indeed a big challenge because, as always, integrated things starting from mathematics is complicated. Frank, are you satisfied with this kind of question? What will be your final take then on this? Please, Frank, unmute yourself.
For rural retentions, it is quite a conundrum because farmers tend to confound retentions for flooding with retentions for irrigation, which will not have to be full at the same time. So it's a big question, and I'd say that they are important but not sufficient nor indispensable. So it's a solution you can use. It's not the solution, and it's not indispensable. You can do well without. But for our big cities in France, you have quite big basins. For the Seine area, which protects Paris, you have 3 big lakes, which are enormous compared to our solutions. So it is a solution. For the question which was asked before on climate change, we do not have much effects on our main problem, which are smaller events. But for biggest events, they may be more consequential. So we have to take that into account for mainly flooding, river flooding protection.
Thanks, Frank. And by the way, let me also highlight again that in France, water utilities have a responsibility now for flood, for river management, which is quite unique in Europe. And we really hope that other countries will take inspiration from France on this, because that will solve some of the additional institutional issues that we were discussing. But I stop here, thanking again all the speakers, a lot of food for thought, and also of work to do for the future. But I think there are some directions that are quite clear. The point is how we move forward, both from a technical, financial, and institutional point of view. But I hand over to Katy to close properly the webinar.
Yeah, thank you, Milo, and thank you all for this interesting discussion. Given the time now, it's time for me to wrap up. On behalf of IWD and also Aqua Publica Europea, I want to thank all our speakers, but also the audience for sharing the experience and questions and engaging into the discussions. Please note that we will inform you as soon as the recording of the webinar and the presentations are uploaded. And yeah, with this, I just wish you a good remaining afternoon and goodbye. Thank you so much.